everyone to another little big lecture. Today we're talking about a really cool topic that you probably have heard of. This one is called dark matter. Probably heard about it. Dark matter is opposite, or I shouldn't say opposite. Dark matter is different from dark energy. You may have heard of the two, but there's actually a very slight, subtle difference. What is that difference? Well, dark matter, as we now know it to be, we don't really know what it is. Well, dark matter, as it turns out, actually holds galaxies together. How about that? I drew a nice big, juicy, chunky galaxy here for us so you can see this is my beautiful drawing. But back in the 20s and 30s, astronomers that were first studying this, including Jan Oort, guy from the Oort cloud, he discovered the Oort cloud, or hypothesized the Oort cloud. Astronomers like him and some others, they actually discovered that there's a lot of excess mass within galaxies. For some reason that they measured the mass of galaxies, including our Milky Way galaxy, and they noticed something a little weird. They're like, that's funny. It appears that the number of stars, if we add up all the little itsy bitsy number of stars, that total amount of mass and energy does not equal what we actually find in these galaxies. Crazy. So they were like, what's going on? So they just basically guessed, one astronomer in particular, his epic name is called Fritz Zwicky. I'm not kidding when I say that. Totally real guy. Fritz Zwicky hypothesized this thing and he called it dark matter. He's actually the one that named it, that coined the term dark matter, because
we have no idea what it is. It's invisible to us. We can only see its mass and its effect on stars and galaxies, large-scale structures. That's when we can
posit that it's actually there. One of the craziest things about dark matter, that the reason it holds, the reason astronomers think that it holds galaxies together, is this weird phenomenon that the stars on the inside, so if I draw like all these little dots over here, I'll have a better image for a galaxy for you guys so you can kind of get a good sense of it. But the stars towards the center of a galaxy, towards the supermassive black hole, such as our Milky Way galaxy, all these stars near the center here, they actually spin much, much faster towards the center. Just like as you've seen the figure skater spinning and spinning, she tucks her arms in, she'll spin faster and faster. The same thing is true for the planets in our solar system. So for instance, Mercury goes around the sun a lot faster. Its year is only about 88 days, as opposed to Neptune and poor Pluto out there. They take much longer to go around. They don't rotate or revolve as fast. So they're not revolving as fast. Well, the same thing happens in galaxies. The stars at the center go around much, much faster in the center of the galaxy. However, out here on the outer reaches, the outer stretches, and in fact, Earth and the sun is somewhere around here. We're kind of towards the outer. We're not right on the spiral arm, but we're kind of more on the outskirts. And we're not that large either, but that's another thing. Anyway, these stars are actually on the outside. While they do spin, they do revolve a little bit slower than these stars on the inside of our galaxy and other galaxies. They don't spin that much slower. And in fact, the further you get out, there's a point at which the rate stops completely. And let's say it's like in the midway point. I actually don't know the actual exact point or location. But around the midway point of a galaxy, after that, at this point, all the stars at this point and beyond, they all revolve at the same speed. And they're not really slowing down anymore. So while they're a little bit slower than these, they actually should be spinning much, much slower than we actually see. Doesn't make a lot of sense. It's pretty crazy. It doesn't really seem to make a lot of sense. So because of that, they don't slow down that much, and so even the outside stars here are actually spinning pretty fast relative to what they should be. According to all our calculations, according to our boys Newton and Kepler, and I think even Einstein, according to all this basic physics, that these stars should really be spinning much, much faster. These stars, in fact, should be spinning so much faster that they should be flung off and be flinging off everywhere. Like, whoa, there you go. Imagine really cool, like, rogue stars just flying everywhere. Imagine our sun just being flung off into intergalactic space. Now, there is such a thing named, like, rogue planets and stuff like that, and rogue stars, so there's probably some out there, there's probably plenty out there in the intergalactic medium getting flung off out of the galaxies. But for some reason, most stars, They are clumped together, and scientists don't know why. And we call that phenomenon dark matter. How about that? That's the juicy factoid for today. So some reason this extra energy, this extra mass, is clumping and keeping our galaxies intact. So these stars should be fleeing off, but something is slowing them down. Something is keeping them locked in here. And it's not the stars themselves. So that's the crazy fact about this. And this was really, as I said, this was discovered by Fritz Zwicky, Jan Oort, and other astronomers. And it was not really fully confirmed many decades later in the 60s and 70s with Vera Rubin, also named after the new cool telescope out there. So Vera Rubin also herself was an astronomer, big time astronomer, and so she discovered this factoid as well. She's like, what's going on? This is dark matter, this is crazy. And so the idea of dark matter really took hold, because initially it was kind of proposed back in the day in the 20s and 30s, but it was kind of an unknown thing, and it took decades and decades of research and really more studies on galaxy formation and the excess energy that is found within galaxies. So that's the big boy thing to remember, is that dark matter is the giant glue stick, or the giant glue that keeps and clumps our galaxies and keeps the stars together. Without it, we wouldn't be here, these galaxies would not be here, the Milky Way may fly apart, who knows. Same thing with the Andromeda galaxy, which may or may not crash into us, so pretty crazy. The other big fact I want to share is it is a certain percent of the known universe. So in fact, all the matter that we now know in our universe is only about 5% of the universe. That's all the everyday matter, that most things that we think of. So we have our ordinary matter here. Ordinary matter being this whiteboard, being this marker, me, this cool tie. Anything that you can think of is just ordinary matter, just the basic stuff. Brains, lights, this wall over here, this cool painting I have for you guys. All this stuff that we think of, any book that you pick up, this is all ordinary matter, including particles. All particle physics is ordinary matter. Pretty crazy. We have only discovered and really studied about 5% of the known universe, because when astronomers and scientists measure all the mass that's out there, they've discovered that a big chunk of it is this dark matter, which makes up about 27% of the known universe. How about that? And we have no idea exactly what these things are. Now, what's dark energy exactly? Well, you've probably heard of the expansion of the universe. That's dark energy. More on that coming up. But the actual literal expansion of space, the fact that it is expanding faster and faster, that pulling apart of space and time itself is dark energy. We don't know what that is either, but as I said, we'll dive into that more later on. So that takes up even more amount of mass in the universe and the energy. But we're talking about dark matter here, which still takes up a very large chunk. Now, is dark matter and dark energy the same thing? Maybe, it could be. It could be like some other gravity from, there's some other big theories about what dark matter and dark energy could be. I've heard a theory talking about like dark matter could be some other gravity from another dimension and it leaks into our universe. Same thing with dark energy. It could be like a dark gravity or something like that, holding galaxies together. I like to think of it as kind of like the garbage of another universe, like maybe all this extra clumping and all this extra mass that we cannot really see. Maybe it's like the garbage of another universe or another dimension is like emptying out its garbage, and so that somehow keeps our galaxies together. I don't know, that's a fun one. It's possible that something like dark matter could be an entire new force that we have yet discovered. That's another possibility that other scientists have speculated on, that maybe there's a whole new force to matter that to the universe that we don't know of. There's four main forces that we talk about. There's electromagnetic force, there's gravity, there's the weak force, and the strong force, which are about particles. This could be a whole new force, which is a crazy idea to think about. Maybe there's other forces out there that we don't know what they are. Another possibility is that dark matter could be another particle. So our particle physics is really growing in knowledge. It's become a big new field in science, is particle physics, and so there could be another particle that's actually creating this kind of effect within galaxies that's holding stars together. So there could be other particles, fun, cool, crazy, exotic particles that actually exist that we didn't know of, that actually are keeping our stars together, clumping them together. Pretty cool there. The other thing that they've noticed is there's this technique There's a technique called gravitational lensing, which is another metric that scientists have used to determine that dark matter does actually exist. What is gravitational lensing? When Arthur Eddington actually proved Einstein's theory of general relativity, he saw that a star was actually warping the light of stars behind it. So he could see that space-time was actually bending and warping things. Pretty crazy. The same thing happens with dark matter here. So the same thing happens if you were to look at a distant galaxy. If you were to look at it through a telescope, sometimes you'll notice that it'll warp and twist. But instead of passing through the light of a star, it just passes through empty space. However, we know something is there because these clumps of dark matter and dark energy as well separate, and they cause the light to bend and warp. So sometimes you can even get like double images of the same exact galaxy. And that's in fact how they confirmed this strange new form of matter, dark matter, because you can see the same image of the exact same galaxy in two different spots in the field view of a telescope. So what is dark matter? We have no idea. It has a ton of mass, and we call it dark because we can't see it, we can't smell it, we can't taste it or touch it. Although I kind of wish we could, although maybe it's safer that we can't. And it's probably passing through you right now. Pretty crazy. The main thing that dark matter does that we know right now is it glues our galaxies together, keeps our stars going in revolution about the center of the massive galaxies, keeps our universe and our stars in line, in structure, so we have beautiful galaxies to look at and to study. Pretty crazy. So we still do not know what dark matter is. Maybe it's just clumps of this weird gravity. Maybe it's something else entirely. Maybe you'll discover what dark matter is in the near future. And be on the lookout for dark matter all around us.
Keeping our galaxy glued together. See you next time.